If we look at our current goal, we have A times A inverse equals to 1. And if we look at the tools at our disposal, we have the 3 axioms of a group, as well as 3 propositions that we've proven earlier. If we go one by one and look at how we can use them, if we look at mol-soc, we see that none of the patterns here show up in our current goal, so we can't use them. We could use 1 mol in the left direction to make a 1 appear. However, we'll see that this doesn't really bring us closer to our goal. So now we see a 1 that appears behind the A, and we could then try to use mol left inverse again in the left direction with argument A. And so we see that we're getting a more and more complex shape here. And if we want to simplify this, we'll actually get back to the initial state. So this isn't really bringing us anywhere. We could have here passed in as argument A inverse instead. So let's see how that goes. Okay, so now we have our 1 appear here, multiplying just the A inverse. And we could, again, rewrite using mol left inverse and make an A appear this time so that we can cancel that A. Okay, so now we could use mol left inverse, however we get back to 1. Same goes for here, so in essence this doesn't really get us anywhere. So we will need to look into the previous propositions that we've proven. So if we look at mol left cancel, what we could do is multiply both sides by A inverse, for example, and then cancel out the A with the A inverse using 1 mol, mol left inverse. So let's try that. Here we will do an apply, mol left cancel, and passing in as argument A. And so here I'll assume that Lean was able to actually find out what were the next steps that we wanted to do. And so by reflexivity, it was able to see that both sides of the equations were the same. Let's see how we could have done it a different way. So if we look at mol ek of ek inv mol, we see that if we pass in a times x equals y, and if we look at our current form, which has a times a inverse equals 1, we could pass in as parameters a inverse, and 1, and this will in turn be the shape that we want. And so let's try that. If I apply mol ek of ek inv mol with parameters, arguments, a inverse, and 1. We also see that our goal is accomplished at this point because what will happen is that A inverse will be equal to A inverse times 1, and Lean is able to see that both sides of the equation, it simplifies to A inverse equals to A inverse. And lastly, let's see if we could have done it using mol 1. So with mul1, we would have our, we could use it in the left direction, where from our A we would have A times 1 to make a 1 appear. So we apply, mul1 with argument A. So what we'll see is A times 1 times A inverse equals to 1. And again, Lean was able to understand right away that from that, with the 1, we could do a mul left inverse, get our A multiply A inverse times A multiplying another A inverse, and we see that all of those cancel to give 1 equals 1, and by reflexivity, that that is valid, and so the goals are accomplished.